Alright, so today is 7-4. We'll be doing arithmetic sequences. You might want a highlighter also. Alright, so 7-4. Arithmetic. Looks like arithmetic, but it's not. Sequence. So we're going to look at different types of sequences. So the definition of a sequence is just a pattern. Whoops, that's an N. A pattern of terms. Some sequences are arithmetic, some are recursive, some have other various forms that we'll explore as well. So today, though, we're specifically looking at arithmetic, and so write yourself the following note. If the difference between terms is a constant number, then the sequence is called an arithmetic sequence. In other words, if it's constantly being increased by adding the same number each time or subtracting the same number each time and being decreased, that's what we call an arithmetic sequence. And then the second note, that constant difference is called the common difference. Common difference. You might want to write all of this down instead of just what you think is important, because it's all important. So this part you have to memorize. Are you ready? This is your general form that an arithmetic sequence will take. And you're going to see these sub things. So A is going to represent a number. And the N represents the nth term of the sequence. So this could be, if N were 1, it would be the first term of the sequence. If N were 2, it would be the second term of the sequence. If it were 3, it'd be the third term in the sequence. So all this sub number is it determines what number of the sequence that is. That's all it does. It doesn't affect the value of the number. Nothing. To find the nth term, so maybe I might ask you to find the 100th term. Instead of having to take the first number in the sequence and keep adding or subtracting that common difference each and every time until you get to the 100th number, that'd take us a long time, wouldn't it? We've come up with an algebraic formula to kind of help us through that. So A sub 1 means what? The first term of the sequence. A, I don't know what the number's value is, but this is telling you take that first term of the sequence, add to it n minus 1. So whatever term we're looking for, the 100th term, the 10th term, subtract 1 from that number, and you're going to multiply it to D. What do you think D represents? Yep, so D is your common difference. D can be positive or negative. I don't like the fact that it's behind the parentheses, especially when it's negative. because then you forget to put it in parentheses and it looks like you're subtracting something. You could easily write the D in front of the parentheses if that bothers you as well. That's fine. N represents the nth term of the sequence. Well, it just represents the nth term. I'm not going to put of the sequence because I don't want you to put the value of that term. And then this, obviously, we've said is the first term in the sequence. And then this one we'll write as the nth term of the sequence. So you positively must memorize this. The more that you write it, the less likely you will to forget it. You're going to use it, well, most of you are going to go up to pre-calc here in high school, so you'll use it up through pre-calc. It doesn't go away. So do yourself a favor and memorize it now. All right, so let's look at some problems. Are you ready? Okay, so example 1, write down the directions because there's different directions for different problems. If you don't write the directions, you're not going to know what's the difference between the two problems. So for this one, we're going to determine whether each sequence is arithmetic. What's the definition of an arithmetic sequence? How do we define it above? What was your first thing that I put in red? That's the very first thing. What was below that? If the difference is a constant number, then it's arithmetic, right? So that's what you're looking for. When I give you a list of numbers, if there's a common increase or a common decrease, it's arithmetic. So look at this first one. So the first one is negative 15, negative 13, negative 11, negative 9, dot, 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 meaning it continues infinitely. Is this pattern increasing or decreasing? It is increasing because as negatives get smaller, they're really getting bigger, right? So what did you have to add to negative 15 to get to negative 13? So if we add 2 to negative 15, we get negative 13. What did you have to add to negative 13 to get to negative 11? Plus 2. And then is that the same thing for here? Do you see how the common difference is always the same, 2? So the common difference is D. So that means that D is equal to 2. So is this arithmetic? Yes or no? Yes. So and if it said to explain why, my answer would be yes, because there is a common difference of 2. So you look at the second one and justify a why or why not. This time we have 7 over 8, 5 over 8, 1 over 8, negative 5 over 8, dot, dot, dot. You're not necessarily looking for a pattern. You're looking for a common difference. So write down what you think. Is this pattern increasing or decreasing? Decreasing. So what do you subtract from 7/8 to get 5/8? 2/8. So minus 2/8. What did you subtract from 5/8 to get 1/8? 4/8. So minus 4/8. What did you subtract from 1/8 to get the negative 5/8? Minus 6/8. Is there a pattern to this? Yes. There's a definite pattern. Is it arithmetic? No. So your answer would be no, because there is no common difference. So that's easy, right, to determine if it's arithmetic. All right, can I take that away? All right, so next page. A different type of example might look like this, bless you. You are to find the next 3 terms of the arithmetic sequence. The minute they told you that it's an arithmetic sequence, you know that there's a common difference. So if it's increasing or decreasing, it's always increasing or decreasing by the same number. So you have to find the next 3 terms. So I'm going to let you do that on your own. We have -8, -11, -14, -17, ... So this is where your answers are going to go. So you figure out what is the common difference, and then what's the next 3 terms. Share those answers with those around you. So what was your common difference? -3. Okay, what was your next, what was the first term that was next? -20, then? Are y'all listening? -20, then? -23, -26. Good. For some of you, it's really handy if you write the common difference below here and then keep writing it, because then all you have to do is visually add those, and add those, right? Less in your head, more on paper, kill a tree. That's right, kill a tree. But you can always replant a new one. Renewable resource. All right, so none of those. Let's kill a tree. It's renewable. Unlike if you. Well, okay, it's not like killing a person where you can't rebuild that person. No, you cannot. You can just make another one to replace that person. It's not the same person. It doesn't matter if you don't have the same tree. But that doesn't matter. It doesn't matter if you use this tree versus that tree. People matter. Trees don't.
Trees give us life. Trees give us oxygen.
That's right. So plant another tree.
So if there were no trees, we would be dead as well.
Plant another tree.
And then you can't replace us. So there's none of us.
Plant another tree. I keep saying this, and in 18 years, none of my students have planted a tree ever.
I planted a tree.
Not to replace the paper that you've wasted.
No, I don't.
Okay. Oh, see, you don't really care. Okay. So none of those examples use the arithmetic sequence formula, correct? This one you're going to want to. Because what if I asked you this? Find the 52nd term in the sequence. Whoops, 52nd. I just spelled that wrong. Term. I'm actually going to write arithmetic because that makes a difference, sequence. So you could, and I'm going to give you the beginning of it here in a minute, you could count all the way, you can find a common difference, and you could keep adding the common difference all the way until you hit the 52nd term, right? I mean, worst case scenario, you could do that. It'd take you a while though, wouldn't it?
Yeah.
Is it possible that you could make a math error? Highly possible. So here's why this one's different. We're finding the 52nd term. So here's the sequence: 7, 11, 15, 19, ... So the very first thing you want to start with is the arithmetic sequence formula. How does that start? Just the general formula. A sub n equals A sub 1 plus, bless you,
plus n minus 1
times d. So we have to find, we're trying to find A sub n. What does A sub n represent in our case here? The 52nd term. So here's where we're going to start to replace. So I've got A sub, and I'm going to replace the n with 52 because I don't know what A is, because that's what we're trying to find. I don't know what this particular A is. Equals, do I know the first term? Yeah, so 7 is our A sub 1, right? Thank you. So I'm going to replace A sub 1 with 7. Plus, what do I replace n with? What are we letting n be? What term are we looking for?
Let's say the 52nd term.
52nd term. Ashley, this is for you. Although, why don't you go after I'm done lecturing? Pass it over to Ashley. Because you can go anytime. All right, so because it's the 52nd term, I'm replacing n with 52 minus 1. What does d represent? The common difference. So what is the difference from 7 to 11? Did you go up or down? So we added 4. Is that the same thing here? And that's the same thing here. So we could add 4 52 times, but we're not going to. So instead, we're going to put the 4 here. Now, we're just going to do the math. 7 plus, what's 52 minus 1? What? 51. Times 4. Do you add the 7 to the 51, or do you multiply the 4 to the 51? Multiply the 4 to the 51. So you've got 7 plus, what's 4 times 51? 204. And then what's 7 plus 204? 211. So A sub 52 is 211. Wasn't that a lot less painful?
Yes.
Than adding 4 52 times? Yeah. So there are important reasons why we develop algebraic equations. This would be one. Okay. So flip that. Last problem. So example 4. You are going to consider the arithmetic sequence. Okay, so we have negative 8, 1, 10, 19, ... So there's your sequence. Is it arithmetic? How do we know?
Because it's the same.
Okay, it goes up by 9. To go from negative 8 to 1, they have a distance of 9, right? Because it's going up, it is positive. And if I add 9 to 1, do I get 10? And if I add 9 to 10, I do get 19. So that's how you should check your common difference, is make sure it works with all of them, because sometimes we make a mistake on the common difference. So the very first question I'm going to ask you on this, part A, it's got 2 parts to it. First thing I want you to do is write an equation for the nth term of the sequence. So this is going to be an equation specific to this sequence. So that if I asked you, well, find the 52nd term, find the 100th term, find the 5,000th term, you'd use the same formula each and every time. So let's plug in what we know. We don't know n, right? All right, so, and we don't know a sub n. So we're going to start off with that general form again. A sub n is equal to a sub 1 plus parentheses n minus 1 times d, correct? That's our general form. Then let's just put in the things we know for sure. What things in here do I know for sure? I know a sub 1, right? I know this one. What is that? So up here I'm going to put a sub 1, right? And then what else do I know? I know d. What's d? 9. So this is my d, right? So that's all you're going to replace. That's it. So we're going to put in a sub n is equal to negative 8 plus, I don't replace my n because I don't know what it is, times, and because this one's positive, you can just put a 9 here. If you want to put it in parentheses because you want to get in that habit in case it's negative, then go ahead and put it in parentheses. But this is what I'm looking for. This is the equation for the nth term of that sequence. You don't have to distribute the 9. You don't have to collect like terms. You can leave it just like that. If you want to distribute the 9, you could, and you could have a more simplified version. What if we did distribute the 9? What would be our more simplified version? Negative 8 plus 9n minus 9. Then what would you do? What could be combined? Negative 8 and negative 9 would give you, so I'm going to put 9n minus 17, right? So this could be our simplified form. These are the same. Either one's acceptable. Which one looks easier to use though? The bottom one, right? Could I have made a mistake from here to here? I could have. I know Tristan wouldn't have, but I could have, right? So you might be more comfortable using the top one because you know you probably didn't make a mistake there. And then you could just use order of operations. So it's your choice which one you want to use. I don't care which of these you choose. Doesn't this look familiar to you? What kind of form is this? If I swapped out the a sub n and the n for some other variables? It looks like slope-intercept form, doesn't it? If this were y and that were x, y equals 9x minus 17. So arithmetic sequences are linear, aren't they? Because there's a common difference. So it is a linear form. All right, so the second part to this and the last part is going to be find the 100th term of the sequence. You use whichever equation you want to use of these two. I don't care which. I'll use the first one only because some people are more comfortable with that. But you can use the second one, you should get the same answer. So find your 100th term. That's what it should look like if you're plugging into the first equation. All you do is replace the n with 100. I still don't know what a is because that's what we're trying to find. So tell the person next to you what the 100th term is. So for some of you struggling with the math, you should have gotten 883, right?
Yep.
When you take the 100 minus the 1, you get 99. Then 99 times 9 is 891. If you don't believe me, do it off to the side. Because these are opposite signs, you have to subtract. Keep the sign the larger. If you subtract 8 from 891, you get 883. Well, what if you use the alternate form, this one? What if you had said a sub 100? The math is actually easier on the second one. Here's what you would have replaced there. It's a 9.
It's like an
Yeah, it's a 9, sorry. Sorry.
Thanks.
A 9. Is that better, TJ? Alright, so then what's 9 times 100?
900.
So all you're doing here is 900 minus 17. And if you take 900 minus 17, you still get 883. Did they or did they not both work? So it doesn't matter which of the two you use, so long as you didn't make a mistake here, right? So just be careful with your math. Any questions on that? So you should have an example for every type of homework problem that you have on tonight's homework. So make sure that you look at your notes while you're doing your homework.